This sees us move on to the next section of this topic. So far we have looked at a rate of a reaction and how we can measure them. We are now moving on to look at the factors that affect a rate of reaction. There are 4 in total that we're going to look at. One of them is a required practical, and so we will spend longer looking at that as there is more depth that you need to know. This slide contains the information for the activities that you'll need to do during this lesson, and I will talk through the other slides with extra information as we go. This one links into the work that you've been doing on a rate of reaction. Can you put these in order of their rate of reaction from the fastest to the slowest? Did you get the order right? Fire is a fast rate of reaction. Remember that combustion is an example of a chemical reaction, as once you've burnt the products you can't get them back. Gaviscon is used to treat heartburn, and once the alkali, which is what the Gaviscon is, mixes with the acid, which is in your stomach, which is what causes heartburn, the reaction, which is essentially neutralization, is instantaneous. Frying an egg obviously takes a little bit longer. Remember that cooking is a process that is a chemical reaction, as per my sign on my door. And then the next one is the chemical reaction of splitting up rocks. Okay, now that is slower over time, and this is caused by acid rain for the geographers rather than from the freeze thaw, because that's a chemical reaction. And then finally you've got the rusting. Now obviously rusting takes a long period of time for it to occur. By the end of this lesson, you will have started to have learnt about collision theory, and this looks at explaining the rate of reaction in terms of the collision between particles. And then you will use that information, most importantly, to explain how temperature affects the rate of reaction. And this is going to be a fairly standard format for these next few lessons that look at the different factors that affect a rate of reaction. This is probably one of the most important slides for this whole topic. This is the explanation of collision theory. This is the underpinning piece of work for this topic. So as it states, chemical reactions can only occur if the reactant particles collide with enough energy. So collisions between the particles is needed for any chemical reaction to occur, but they also need to have enough energy in them. The frequency of those collisions with enough energy increases the rate of reaction. So the particles could collide really frequently, but if they don't have enough energy, nothing's going to happen. So for example, if I cracked the egg onto the work surface instead of into a hot frying pan, the particles would collide, but there wouldn't be enough energy, and so the egg wouldn't cook. And we all know that if you put an egg into a pan of warm oil rather than hot oil, it takes a lot longer for the egg to cook, and that's because some of the particles will have enough energy but the others won't. Whereas if you put the egg into an absolutely boiling hot pan, then it is going to be fairly instantaneous for the cooking. Now this next slide shows the practical that we would have done had we been in school, and I have linked up in the instructions a YouTube video that goes through this practical, and I've also asked you to write down the results from that practical so that you can then use it to write a conclusion. This reaction looks at the reaction between sodium thiosulfate and hydrochloric acid. Now when we combine those two, a precipitate of sulfur is formed. Now precipitate is a solid within a liquid, and it makes it go cloudy. And so by placing the conical flask onto the black X, what we can do is to time until we can no longer see that X. And that is when the precipitate becomes really cloudy, and therefore you can no longer see it. The key thing that I want you to do here is I'd like you to watch the videos that I've linked up above to write down the results, and then I want you to talk about the how temperature affects the rate of reaction. The absolutely critical thing here is that it's not about more collisions of particles, it's about more frequent collisions. Because no matter what we do, if I have the same volume of hydrochloric acid and the same volume of sodium thiosulfate, those particles will all collide. It's just about how long it takes for them to do it. This shows a very typical exam question. Here you have the rates of reaction practical and you've got a set of results. Now they can do lots of different things with this question. In this case, on the next slide, they ask you about scientific inquiry. So they're asking you about accuracy and precision rather than specifics to do with the practical. However, I have seen this question where they've asked you to draw a graph of the data. I have asked this where they've asked you to explain what is happening, and I've also seen it where they've asked you to think about whether it has doubled the rate depending on the time. So remember that any information that they give you at the start of the question is just as important as the question itself. They will be expecting you to use it. Here are the answers to the exam question. Please make sure that you've checked them. If you are unsure about any of the terms that they've used in terms of accuracy, precision and reproducibility, if you go to the AQA website, there is a file called subject specific command words, and in there that lists the words that they talk about here in terms of accuracy and precision and give you definitions for them. It's well worth having a look at, as it will give you good guidance to the things they're talking about in the exam papers. And finally, this is really a summary slide. This explains how temperature affects the rate of reaction. Please use it to check the conclusion that you wrote from the video results. If you haven't got anything or you've missed anything that's on this slide, please feel free to add it in your green pen, of course. It's really important that you remember that it's the how frequently or how often the particles collide and the fact that they need to have energy. Temperature is the only factor that changes the amount of energy that the particles have. All the other factors we look at just change the frequency of collision. So be really, really careful on this when writing answers to exam questions.